Hello, welcome back. I'd like to provide some context to the video you just watched. Let's go back to the chart that we have about counting lists and sets of objects from a set of size n. Most recently, we've been talking about k combinations from the set of n objects, and the number of ways to count those was n choose k. And in the video you just watched, we were investing k multisets, which is a way to create a k set of objects from S where repetition is allowed, and we learned that the number of k multisets from a set of size n is n multi-choose k. So let's remind ourselves of how we can count how many ways you can choose k objects out of n. Our gut reaction should be that the answer is n choose k because we're choosing k objects out of n. Let's take a quick detour. It's important to recognize that n choose k is the same as n choose n minus k. You can prove this using the formulas for n choose k. N choose k is n factorial divided by k factorial divided by n minus k factorial, while n choose n minus k is n factorial divided by n minus k factorial divided by n minus k factorial, which is the same as k factorial. But there's an even better intuitive way to understand this. N choose k counts the number of ways to choose k objects out of n. So if we went to the animal shelter and decided to take home k cats out of the n that they have, the number of ways in which we could do that is exactly the same as the number of ways to choose the n minus k cats that we are not going to take home. In how many ways can you choose n minus k cats to not take home? It's n choose n minus k. And something that feels pretty natural is that if we're trying to take k objects out of n, then k must be less than or equal to n. It's not going to be possible to take 9 cats home if there are only 5 cats available at the animal shelter. So that's the idea of choosing k objects out of n where there is no repetition. But if you allow repetition, you're in this situation of multisets, and just like when we were choosing k objects out of n, you recognize that the answer is n choose k, you should have a same reflex that when you are choosing k objects out of n and you allow repetition, the answer should be n multi-choose k. Now in the previous video, you saw that n choose k is equal to n plus k minus 1 choose k using the stars and bars argument, which means you can apply the formula for binomial coefficients to get an actual number for n multi-choose k. But do be aware that unlike for binomial coefficients, when you have n multi-choose k, k is not required to be less than or equal to n. Let's see a quick example about this. Let's say you head down to your neighborhood bagel shop and you want to choose a dozen bagels, and the shop has plain bagels, sesame bagels, poppy seed bagels, and everything bagels. In how many ways can you make a dozen bagels? There are 4 types of bagels, and you want to choose 12 of them with repetition. You're allowed to get 10 plain bagels. You're allowed to get 5 everything bagels. You're allowing your order to repeat different types of bagels. And let's make sure we're all on the same page about how these multisets correspond to stars and bars. Of the types of things that we can count, we have multisets. Remember, we're using these angle brackets to represent a multiset, and our multiset has maybe 5 plain bagels, 6 sesame bagels, and 1 everything bagel. This corresponds to 5 stars, 1 bar, 6 stars, 1 bar, 1 bar, and 1 star. These 12 stars represent the 12 choices that we're making. There's 12 bagels to choose. And the 3 bars represent the 3 dividers separating the 4 different types of choices that are available. All of the stars before the first bar correspond to plain bagels. All of the stars between the first and the second bar correspond to sesame bagels. All of the stars between the second and the third bars correspond to poppy bagels, and we decided to not choose any poppy bagels. All of the stars after the last bar correspond to everything bagels. And this type of visualization is helpful to understand why this 4 multi-choose 12 can be written as 4 plus 12 minus 1 choose 12 because there are 3 bars and 12 stars, and we want to choose in which positions we're placing the bars or in which position we are placing the stars. In effect, we are choosing the position of the dividers that separate the bagels into bins. That's it for now. See you shortly.